This is Calculus with Allenson, and today we're going to be doing problem number 2 from Form B of the 2005 BC test. Okay, so we've got two functions, W and R. W is the rate at which the water is pumped into a tank, and R is the rate at which the water is removed from the tank. It's going on for 18 hours and 12,000 gallons of water in the tank to start with. So, A, is the amount of water in the tank increasing at t equals 15? So there's some amount of water going into the tank minus some amount of water going out of the tank, and we get negative 121.09. That means the water is not increasing because this is less than 0. Okay. B says to the nearest whole number how many gallons of water are in the tank at time t equals 18. So we have 1200 gallons to start with, plus the integral from 0 to 18 of W of t minus R of t. And so plug that into your calculator and get, and it says to the nearest whole number, and so we get 1,310 gallons. C says at what time t for 0 is less than or equal to t is less than or equal to 18 is the amount of water in the tank at an absolute minimum. Show the work that leads to your conclusion. So it's going to be at a minimum when when these values are 0. Okay, when the difference between the rates of water going in and out is 0. So we solve for that and we get that happens at t equals 0 and 6.4948 and 12.9748. You also need to consider the endpoints. 0 happens to already be there, but you also have to worry about 18. Okay, so now we want to find what happens when we plug these in. What do we get? How many gallons of water are actually in the tank at these times? And so we have to figure out all those values. At 0, it's 1,200. At this one, at 6.49, it's 525 gallons. At 12.97 hours, it's 1,697 gallons. And at 18, it's 1,310 gallons. And so the minimum obviously happens at 6.49 because that's when it's the least, and so the minimum is at t equals 6.494. or 6.495. D asks you to, or it says that for t is greater than 18 hours, no water is pumped into the tank anymore, but water continues to be removed at the rate of R until the tank is empty. Let K be the time at which the tank becomes empty. Write but do not solve an equation involving an integral expression that can be used to find the value of K. Okay, so we know what happens is after 18 hours there's 1,310 gallons in the tank. Okay, so we have to consider that this is how much water is in the tank, and it's just being removed with R now. So it's still accumulating the amount that we're going down from 18 to some value K, R of t dt. That's going to give us the amount of water that's being removed. I want the amount of water being removed to be 1,310. the points for this problem come 1 point for A, for getting the answer no with a reason. Okay, it's less than 0. B, 1 point for the limits, 1 for the integrand, 1 for the answer. C, 1 point for the interior critical points, so here 1 point for the amount of when the amount of water is least, which is at this one, and 1 point for an analysis for the absolute minimum. D, 1 point for the limits of integration, and 1 point for the equation.